I'm not a medical doctor, so I will not help you. A few things about me. I'm active in open source. You can find me on Twitter. I was lucky enough to have a unique last name, so you can find me everywhere. I spoke at previous conferences, but it's really exciting to be here because at previous conferences, no one spoke about security, which is a huge oversight. And this time, I'll be speaking about security. Dave Smith will speak about security, and there'll be a Q&A panel, so we want to talk about security. I forget things, so I write them down, right? So I have a very active blog, and specifically for AngularJS, there are almost 60 blog posts, mostly about Angular 1, right? Because Angular 1 has been around for a while. So I talk about Angular 1, and usually it's very practical. It's like unit testing. How do you do unit testing with Angular? Or how do you stop silent Angular name overrides? So how do you improve performance? So whatever is practical advice for my team hopefully applies to your teams as well. So about my team, I work at a company called Kensho. It's in Boston and New York City. We provide data analysis for large financial institutions. Mostly people can use our web app to say, if it's really cold weather, how does it affect price of Coca-Cola or bananas, things like that. And it gives you all the stats and all the analysis so you can make a decision. But this presentation is not about this. I was listening to the keynote, and the keynote gave me an impression this is the future of web apps, right? Angular 2 is very powerful and makes a strong statement that it's the framework of a year or the next year. So kind of like city of the future with flying cars, robots, whatever you want. And this presentation kind of feels like this, which is Uruk in modern-day Iraq. The city actually existed 5,000 years ago. It's the first place where we found the clay tablets with written speech. So this presentation is about Angular 1 and kind of Angular 1 1.0 kind of situation. But hopefully it will make sense. So here we are today, 2016. I'll start with this presentation about the work I've done in 2013, which is very old. And then we'll talk about what we have today and other frameworks and security threats. Then maybe we'll finish with a little bit of a future stuff. And since it's the theme of a conference was 80s, I just have a picture of 1985 E30 body, BMW that I used to drive, black. Look, it was beautiful. Okay. The only thing that you have to remember about security, if you remember anything from my presentation, is the security is compromised when there is a mismatch of expectations between two parts of the system, right? It could be two libraries, could be server versus website, could be mobile versus server, could be two different functions. When there is a mismatch of what these two things expect from each other, then there is a hole that security attackers can exploit. So for example, we can have a database call, and the database call uses concatenation, and it assumes that the email is valid and sanitized. So it just uses concatenation, because it thinks the email is actually an email string. And a website says, okay, the database probably will sanitize the email, so I'll just pass whatever user provides in a URL, for example, to find a particular user by email. Okay, two assumptions. So what happens if someone enters email or 1 equals 1, or true condition? And I'm kind of like omitting all the escape characters. Well, this string is no longer email, but it is passed to the database layer, and database just uses concatenation and returns you every user from the table. And that's how you grab all the usernames and admin accounts and so on. So this is an example of injection attack. The website assumed that the SQL layer is robust and validates everything, but the SQL layer assumes that whatever inputs are already sanitized. So mismatch of expectations. And we will see it over and over again in this presentation. So in 2013, I worked at a company called UTest. Now it's called Applause. And what we've done, we took the data from mobile tests, from crash reporting, and App Store, and we made money. The way we made money was like this. So let's say, Snapchat. You go to the App Store and you read reviews, and sometimes reviews are positive, sometimes they're negative. So for example, in this review, it's a negative review, and the user complains about performance and crashes. And when you analyze like almost 1,000 reviews, and you say, okay, but performance seems to be a factor. And performance, if you do statistical analysis, kind of means 2 stars. So this particular app suffers a penalty of 2 stars because it has bad performance. UI features, it probably suffers for half a star. So if its current rating is 2.5 and you improve performance, you should expect a review of 4.5, which is very high. So we've done that, and we're like, okay, let's get all this data. Let's write ourselves a dashboard, Angular 1, node, data sources, multiple audiences. Beautiful, right? Kind of job you like. So a designer, and this is how I imagine a typical designer, gives me a mock-up, and this is how I imagine myself. I give back a website. Normal, okay? The tools that designers use to create mockups are pretty advanced, like Balsamiq here. It's pretty much animated functional components that they put together. Business idea, right? Take design mockups and generate live web components, right? So if anyone wants to do it, that's a great idea. And this will put all of us out of business. So the only thing that protects our jobs from designers overtaking is REST. So that's why I don't like GraphQL. But anyway, a lot of my job was pixel pushing, right? So I do something and then, oh, this is misaligned. Okay, it wasn't that bad. What was much worse was color. So designers don't think about color the way I think about color. They use, hue saturation value. So the hue would be like red, blue, like the actual color name. And then saturation would be gray versus full red color. And lightness would be dark versus light. So they use in terms of hue saturation value and emotions. So designers will say, red, I want bold colors. I want them to pop up. And I was like, F00, free, like, well, what do you mean? The worst was when the designer would say, I don't like this background. Can you change it to this? I was like, it's the same background. He's like, no. These are 2 different backgrounds. Right? I don't see it. The final result from a designer would give me a swatch, right? Which is a collection of colors to be applied to a website. And it's one thing to see a swatch. It's completely another thing to actually see the live website with those colors. And so what happened was a lot of back and forth. I would apply colors, deploy the website, designer would look at that, I don't like it, can I sit with you and we'll do that on your machine, right? Or I could teach the designer and maybe deploy the website locally on the designer's machine, but that's kind of hard. Maybe there could be something better. So I created an Angular tool called Color Pusher. And let's see if I can show it really quickly. I have a demo. So if you have a website, especially if you have Angular website, you can just pop this thing and say, okay, I want my dominant color to be, let's say, purple, right? And then I want to generate maybe all the other colors automatically. I want to apply it, and boom, I can see the result right away. This purple is kind of not what I like. Let's kind of maybe make it a little bit pinkish. As you can see, it changes, right? So you can vary all these things. So the designer can just sit there, push colors as much as he or she wants, and see the results right away. Angular 1 was an excellent project, used Bootstrap and so on. So I've done that, and it's an open source project. If you control the page, it's easy to include it. It assumes jQuery, Angular, Bootstrap, and you just have to add CSS and JavaScript. But the problem is this. If you want to actually use it on your website, you have to put maybe a feature switch or some kind of conditional. You don't want this to be in production website, right? People don't want to see this color pusher on production. So you have to do something like this, which I don't like personally because it adds complexity, adds one more thing I can forget. So another thing you can do is you can actually create a code snippet. So let's say we have Angular Connect, right, website. I'm just going to open the DevTools, and I'm going to go to Sources, Snippets, and I have this snippet, which is pretty much the same code. It just loads Angular, loads things. And if I run this, then, well, maybe not yet. Let's see what it is. Oh, of course, not everything loaded. Let's try it again. Okay, so this actually created color pusher. It inserted this widget into Angular Connect website. So now I can, for example, vary colors on a live foreign website, right? Kind of like this. Which is amazing because I have not updated this widget in 3 years, and it still works with different color of Bootstrap and jQuery and so on. Okay, so I can do that, but that's also kind of complicated, right? Like, the designer doesn't know how to use code snippets. So widget requires changes to the page, creates extra feature. Code snippet requires you to know how to use DevTools very well. So why don't we write a Chrome extension? Like, that's the easiest thing for designer to be used. It can auto-update itself if I release a new version. And we can actually make a DevTools panel. And so I wrote Color Pusher Chrome extension, which is I took the Angular component, wrapped it in a little bit of code, and released it as Chrome extension. Let's see if we can have it anywhere. So I have this website. I can open Color Pusher Dev panel. I probably should make it a little bit larger so we can set the lines. Okay, so the same kind of thing. I can apply colors and so on. The cool thing about dev panels in DevTools, if you have it open and you open another DevTools, when you have a DevTool for DevTools, and if you look at elements, you can actually inspect the panel. And as you can see right here, it's just iframe running your Angular application. So if you know how to write an Angular application, that means you know how to write a desktop app, mobile, and also DevTools panel, which is a great multiplier. Okay, so we can do that. Except I had to do a bunch of modifications. For example, I don't want to rely on CDN anymore, right? Because if there is no Wi-Fi, my DevTools panel would not load. So you can include all the libraries. You can still include CDN, but you have to use HTTPS. And the Chrome extension docs are really explicit, and the way they say what you can do or what you cannot do is actually by whitelisting what you can do, which is a very important point, as you will see in the future. So for example, they whitelist what you can load. In this particular case, HTTPS. And you will see over and over again that as a general security rule is that whitelisting of allowed things works. And blacklisting never works. People will always find something else that they should not be doing, but they can. So the blacklisting is a bad approach in general. For example, let's say I want to write 2 lists of websites. One list is websites I trust, and another list of websites I don't trust. My trusted list could be very short. My untrusted, blacklisted list could be infinite. Right? So whitelisting rule could be much shorter and much harder to break than blacklisting websites. Okay, so for example, whitelisting HTTPS and secure socket connection is a very simple rule, and it's a lot more powerful than blacklisting HTTP, WebSockets, whatever other protocols. One interesting thing is that in the original web widget, right, that was embedded in a page, I could have a feature where I could load the whole color palette from external website using JSON-P protocol. In Chrome extension, I don't have that. And I cannot have it because what happens, the website I'm loading this thing from does not allow HTTPS. And JSON-P protocol under the hood, when you call it using HTTP service, actually creates a script tag and loads that. Right, just as if it were loading JavaScript. So this means, and the JavaScript kind of looks weird, but because Chrome extensions cannot load things from HTTP, I have to cut that feature, which might bring a question: why do do I have to use JSON-P, and why can't I use CORS or something secure like HTTPS? And this goes to the whole security problem of the internet. So in 1989, World Wide Web has appeared. And then in 2000, AJAX appeared. 2004, JSON-P has appeared. And only then, a couple of years later, CORS, cross-origin requests, have been invented. And right now, we're like something around here. So it's already, as the World Wide Web evolved, there are many, many layers of features that now start to interact. And the bad thing about this, and what makes security very hard, is that the standards for like World Wide Web versus JavaScript versus the internet that actually runs things are controlled by different organizations with different timelines and different priorities. And what this picture doesn't show, the whole other mass, which is the browser support on top of all that, and how all the versions of browsers implement different features. So one thing you have to remember when you're doing internet, or internet security, or your website security, is that the internet is like Rome. It's a huge city that has evolved over 3,000 years, except this giant city was built on top of another ancient city. But now there's huge construction going on in all the different places. But not only that, it's only planned in 2-week sprints. There is no long-term vision. Everyone's doing their own thing with very short-term time horizons. So that's why security is hard. And what I really recommend is reading this book, The Tangled Web. It's excellent. It goes into security, implications of different features, and how they all kind of work together against you. Okay, anyway, back to the Chrome extension. Another thing that I had to do, I had to add this directive called ngCSP to actually allow Angular to run in Chrome extension. Quick definition. So inline script is script inside the script tags or on-click handler. External script is everything that's loaded. Same with inline styles. If you have a style tag with CSS, or if you have a style attribute, it's all called inline styles. External styles, something you load. Chrome extension DevTool panel has to run in a content security policy that disallows internal by whitelisting and saying only external styles and scripts are allowed. So I could not use anything. But Angular 1 uses eval and inline styles by default, right? So if you load Angular, you will know that it actually creates this style tag in your header that actually loads all the styles. Because I'm running a Chrome extension, it cannot do that. So you have to use this ng CSP to disable inline styles. You have to include them. And you also disable eval, which makes parse service a little bit slower, but doesn't use eval anymore. Okay, Angular 1, lockdown mode, really easy, just a single directive, and you're good to go. So that was prehistoric history, present day. I work at Kensho, financial institutions. We all care about security, and we're like, well, if there's a security attack, we'll never find out, all our customers will run away, and it will be over. So not many people know that you can skydive without a parachute, right? But only once. Also, not many people know that for a startup, you can have your security compromised, but only once. We don't want to be the next Yahoo, if you know what I mean. We don't have that kind of capital. Okay, so in order to give a framework to security, we don't have to reinvent the wheel, right? The security on the web has historic roots, and the best project that kind of looks on overall security and the threats is called OWASP, Open Web Application Security Project, and they publish this top 10 security threats. The latest compilation is from 3 years ago. If you go to the website, we're actually conducting a survey for this year, so soon there'll be a different list, but I think the major components of that will be the same, maybe with the order changed. The top one is injection attack that I showed before. And then there's a whole bunch of other things. I recommend that you just go back home and you watch these 3 video courses, like an hour and a half, from Pluralsight, that will go through each of the 10 security threats, and we'll explain how it happens and how to mitigate. I will only look at these three topics: authentication, cross-site scripting, and insecure third-party code. Dave Smith, right here. Dave, can you wave? We'll talk about cross-site request funkery, and also we'll have a panel on Q&A panel on security later today. So if you're interested in security, it's great that we have 3 security-related events today. Okay, first security threat to your web apps. Number 2 on the top 10 list is authentication session, or how, I remember, like, who are you again? So if an attacker can impersonate someone else, then it will be bad, right? And the most important problem there is that the authentication mechanism, let's say a cookie or a token, is sent and it gets intercepted by an attacker and then used to impersonate the user. So my only suggestion right there from the bat is to use HTTPS for every communication link, so that in the middle, an attacker cannot intercept that. And I have HTTPS with asterisk here, because HTTPS can be bad. There is a SSL Labs organization, and they have a free test. So you go, you put your website, and they'll analyze the SSL protocol and all the ciphers that they use to encrypt messages, and they'll give you a grade, and they'll explain how to solve the problems. Even large companies like Ford Motor Company, their credit website gets an F because they use absolute versions of the libraries that are easy to hack, they're exploitable, and it's just really bad. So you want to get at least an A, and it's easy to get an A. One thing that's very common is that you don't configure your server to deny weak encryption protocols, weak ciphers. So for example, this is my configuration that I usually apply. On the top, the server says to the browser, use these ciphers, but are really strong, hard to break. And in yellow, I deny using weak ciphers, so that the client cannot even communicate thinking it's secure, but using very weak encryption standard. Second common thing is that you only use SSL for some things. So for example, I have my personal blog or website on GitHub Pages, which is HTTP. But it looks like I have HTTPS because I use custom domain from Cloudflare. Now, when the user connects to the Cloudflare, everything is fine, good security. But then the Cloudflare communicates with GitHub Pages over insecure channel. And so attacker, it's hard, but potentially could intercept that. Now, why don't I turn on HTTPS? Well, because GitHub, for example, doesn't allow HTTPS if you use a custom domain. Now, I don't have any web apps or anything meaningful to exploit, so I'm okay with that. But if you're making a website, kind of having just a proxy that redirects to unsecured connection point is a bad idea. Another thing is that you can communicate securely, but you don't store the authentication token in a cookie, for example, securely. So make sure all your cookies are HTTP only so that JavaScript cannot get to them. And mark secure, that means they can only be sent to HTTPS websites and not to HTTP when they can be intercepted. And also same side, but I'm sure Dave will talk about that. So my general advice, just don't implement your own session management, your own password security. Just leave it to professionals. A lot of finer points, for example, brute force attacks, password resets, are all weak points that you don't want to spend time implementing, and you should probably use like Firebase, Auth0, backend, people who know what they're doing in that particular domain. So just leave it to them. My favorite thing is cross-site scripting. And the cross-site scripting is always a confusion when you think, oh, is it data or code that's running on my website? And here's what happens. Let's say you have a field, and you ask user, what's your name? And then you have a template using curly braces, and you put the name there, and it's displayed in your browser. Everything looks good. What happens if a user actually puts script tag there, right? A piece of code. Well, it will be placed by the template engine into the DOM, and now you have to ask yourself a very important question. Did your framework or library use inner text, which is safe, or inner HTML to actually put that content into the DOM. If it's inner text, it's fine. It's treated as text, it will not be executed. But if it's inner HTML, then you have to ask a second question. Did the framework or library properly escape all the angled brackets? Oh, that's why they call it Angular. Okay, now I get it. Okay, why do people want to use inner HTML? Because if you want styles, let's say you're doing an editor, right? You want actual styling, so you might want inner HTML. But what is really dangerous is that if one user can enter content and then you display it for another user, right? And that's why it's called cross-site scripting attack, when you go from one user to another. And what usually happens is that you have your website, you have your own content, but you also, for example, have user comments. And if one user enters something that other users see and it's an attack, it could be sitting somewhere else, quietly stealing session IDs, stealing passwords, intercepting all the communication. So the question you want to ask yourself, will the content or script embedded in the user-entered content be executed for another user? And the hard thing why these attacks happen is because you have to kind of prove that it will never happen, right? You have to have a blanket statement, but there's not even a chance, a 1% chance that this will happen. And this is hard. And we always say, no, it will never happen to us. Like our code is handcrafted, artisanal code. Story time, okay? If we had a fireplace, we would just sit and I'll tell you a story. How bad things happen to good people. So everything starts normally. You have a server-side rendering that uses Jade. It has a greeting field, and it puts that greeting into a h1 tag using greeting. If it's hello world, the user sees hello world. Everyone is happy. Someone enters the script tag, well, Jade actually escapes everything, so everyone is happy. You will see some, just a text. If a user enters curly braces, well, the curly braces will be there. Weird, but so far, so good. And then someone adds Angular, right? And adds ng-app. And all of a sudden, this curly braces thing becomes Angular template. And now it gets executed all of a sudden. Okay? And you say, well, if someone actually puts script tags where Angular, better not execute it. And it's not executed. Angular sandbox prevents obvious script tags from actually running. And then someone comes along and they say, well, instead of just doing like 2+2 or a script tag, I'm going to say constructor.constructor and a string. And what happens? Boom. It actually runs. Not only it runs, but template is not actually reflected in the DOM. So if you look at the template, you don't see anything. It's not like you see constructor, because the DOM only has the result. In this case, empty. And it runs on every digest cycle because the template expressions, right, are evaluated every time. So potentially, if the code, the malicious code from one user actually did something, it could be running all the time in the background, doing all its evil things. And again, this is a mismatch of expectations, right? You have different components that by themselves are safe, but taken together, they generate a hole that someone can exploit. So one thing about constructor, and why it's hard to actually secure this. We think of JavaScript objects, right, as this kind of standalone things. But in reality, everything is connected. At least we know it's connected to its prototype. But also, every time you do something, there is a constructor property. So a single object is connected to its parents, and it's connected to whatever constructed it. So you can escape different ways. And if you have a dumb thing, like an event, then you can escape and get into the window and document. So let's say a brute force attack like eval, it doesn't work in Angular, but you can write, instead of eval, you can create a function using function constructor. Doesn't work because Angular thinks it's a scope property, so it doesn't work. So we need to get functions somehow, and that's this thing where every object has a constructor, which is function object, the prototype function. And if you do constructor of that, that's a function function. So you kind of get into the ultimate creator. and that's this attack. So you think, okay, this will never happen to me. I'm not using Angular 1.0. You know, I'm past that. You know, it has been fixed in Angular 2. You're safe, right? Boom, right? No more constructor. You actually get an exception if that runs. But the way they implemented this was this, and this is the code from Angular 2. They have functions with names like ensure safe member name, ensure safe object. All of these things is a blacklisting of things you should not be able to access. And as a general rule, the blacklisting doesn't work because someone will sit around and they'll find some other way that they can, do bad things. Even worse is that right above the code, right, to ensure a safe member, there's a big comment in code. Sandboxing Angular expressions. And the first sentence, it says, Angular expressions are generally considered safe. Okay? Right after that sentence, I stopped reading, because that's all I need to know, right? They use blacklisting, and they set very high expectations. And in general, a combination of the two is very hard to pull off, no matter how good of a developer you are. So, Angular 2. Here's an exploit. Looks weird, right? Okay, this has been fixed. Angular 3. Boom. Well, 1.3. Exploit starts looking really nasty. 1.4. And you might ask yourself, what kind of people can write those exploits? And this is how I imagine, breaking a sandbox and searching for, a hole in a sandbox. And if this loads, okay. So you see a sandbox, and you're like, I need to get into that sandbox. So I'll just, boom. I'll try a brute force attack, and and then, I'll try it again. So you search for, common things. You try, getting constructor. You try doing this and that. You kind of broke in. You kind of squeeze in. You hold your flashlight in your mouth, right? Like this is the work of a hacker, right? Exactly, and then you find out it was open all this time, okay. Why am I talking about this all code in 1.0? If you go to the website made with Angular, and please don't, we're not trying to encourage, hacking. Bunch of websites are running older versions of Angular today. The larger the company is, the more likely they are to be running a very old version of Angular, like JetBlue, Ford, Viacom is still there. So these exploits and escapes are still relevant. And if you're running Angular 1, you should know about that. Okay, so I love Angular 1. Simple, powerful, has performance problems. So I looked at the Vue.js, which is pretty much Angular 1, but with different, change detection that's fast. And I was like, okay, I like that. What about security? And if you look at security, the syntax for HTML explicitly says the double mustaches, right, interprets the data as a plain text, not HTML. In order to output real HTML, you will need to use triple mustaches. So we're setting up expectations that it's secure. Boom, constructor works like a charm. So if you know the exploits for Angular, you can exploit our frameworks. Not only that, Vue can give you access to the actual DOM element, and then you can do whatever else you want. Aurelia, another good framework, specifically in their security page says, internally, Aurelia makes no use of eval of a function constructor. All binding expressions are parsed by our strict parser, which does not make globals like window or document available in binding expressions. We do this to help prevent some common abuses. Again, setting very high expectations, yet not delivering. Finally, the Google team this month just announced, okay, we give up The blacklisting is not a solution, right? It adds a lot of extra code, it decreases performance, and it's easily bypassable. And the existing of this sandbox only made some developers incorrectly believe that the expression sandbox protected them from cross-site scripting attacks. So I actually welcome this news. Let's get rid of it. It was just setting false expectations of security. We have to find something else. Angular 2, there is no sandbox, and this escape still works. Now, Angular 2, you have to pre-compile everything, right? It's not like you can put things in a page. So this is much better. And the security explicitly says that Angular templates should be treated as executable code. That means you have to be really careful not to treat user data as template or as executable code. So if you cannot sanitize your way out of cross-site scripting attacks, what do you do? And the solution that I propose, and I've been using myself, is disable inline JavaScript altogether. So inline is whatever is in page. External is all the external script tags. And the assumption here is that the attacker is trying to get code into the page and probably cannot control the server code. And the best thing to do that right now in all the browsers is to use content security policy header. For example, in this one, I'm disallowing all scripts except external scripts from the self, from the domain, or from specific version of Angular. Like that's how you want to specify things. So there will be no inline script. If you really want to see a strict security policy, just curl GitHub headers, right? And you will see a good example of content security policy. GitHub is a classic example of a website that shows user content. If someone found a way to break GitHub and actually execute a cross-site scripting attack, that would be probably bad. So they actually put a lot of thought into this content security policy header. You don't have to use the header. If you cannot control the website, you can put it in a meta. So that's the simplest way to do it, like right now. And it's the same thing. So back in our example, our server adds this content security meta, disallows inline, and now there'll be an exception if you actually try to use constructor. But if you have a regular expression, everything is working. So that's nice. We achieved our goal. We disallowed brute force content security policy attacks. Setting is very simple. For Node.js, there are a whole bunch of ways. I recommend using Helmet that puts all the script tags, all the content security policy tags there. And you think okay, let's start using it today, right away. The problem is this, in principle. We inject a lot of variables and a lot of configs by just doing inline scripts, for historic reasons, right? Sometimes you can have, analytics IDs and so on. So we generate this inline when we render a page, and then the rest of our scripts can use these values. My solution was to take everything that you used to inject inline and render separate external files. So for example, instead of inlining, you would actually render a separate external JavaScript. So we wrote a middleware from JavaScript to JavaScript, and all its purpose is to avoid inlining config variables. And you can do things like values. You can actually do, you can wrap your inline Google Analytics script, whatever you want. So for example, Angular Connect, the only thing the website is missing to do this is the Google Analytics script that's inlined. You can wrap it around and get rid of it. You can even generate a huge config object and just pass it all at once. And the lesson is you can take any server, and with a little bit of effort, you can get rid of all inline JavaScript or styles altogether. We even done it for our Django Python server. So you think, okay, I'm sold, just give me this middleware. Okay, it's free, just use it. But I have to mention some downsides. There are 2 links here that discuss how some attacks are not prevented using this content security policy, like I showed. The main problem there is that instead of creating new function and evaluating it, we actually reuse existing function to do malicious stuff, or they try to actually get to the window object and then just do something with that. So there are attacks that bypass it. And I said these attacks are weird because I'm not sure about their severity or how easy it is to achieve that. Again, the solution is pay close attention to what the user enters and make sure to never treat that as a code that you can execute. A couple links to things in Angular and external tools that can help you sanitize the user input and maybe remove all malicious data. Okay, tomorrow. Angular takes advantage of web workers. Other frameworks also started using advantage of web workers. What about content security policy? What if there is malicious code there? If you create a web worker using create objects from a blob, then the content security policy of a document applies, right? So you cannot use eval. So that's good. But if you actually load an external web worker from a script, then you should actually set the content security policy on that script as you return it, which is different, right? We used to only set it on HTML. Now you have to set it on script as well. Now, the bad news about all of that is that this is content security policy level 2 spec, but it's not implemented across all the browsers. Different websites give different values, but pretty much you can guess who doesn't implement it. Okay. At least try to control where the HTML page can load the web worker code from by using child source content security policy property. Okay, the really scary stuff. If an attacker can load a service worker with attacker's code, it's really bad. Basically, service worker is a proxy that sits between your page and the server. It can intercept everything. It can modify the page itself. It can load new things. It can cache, do whatever it wants. And if an attacker can load that, it will be very hard to get rid of it, because that service worker can constantly reinsert itself into the page, can prevent the actual service worker from loading. We have to think about really carefully. Interestingly enough, the Chromium team is looking at that, and the attack that they think is possible in order to load a malicious service worker is through JSON-P. The JSON-P is the cancer of security. Yeah. Okay. The last thing I want to mention is running insecure third-party library code. And there are a couple of problems. We all like, reusing code. We like, okay, just add this library and it will give us, what we need. But are you using a third-party library with a security exploit, right? An attacker doesn't have to, break your code. If you're using third-party library that the attacker knows a security hole in, they can just do that. So there are a couple of projects that allow you to monitor the security holes and maybe be warned. Greenkeeper keeps your code up to date so that you stop using a version with known security vulnerability. And if you're using old versions of Angular or any of the libraries, it's not just technical debt, it's a security risk, because as soon as there's a known security hole, the attacker will go around and find all websites that use the security hole, and if you haven't upgraded, boom, you're done. But there is another problem that I think is even worse, is we assume that the attacker only goes through the website or through a web app, right, and attacks our code. What if attacker could actually modify the code on our server? And here's how one can do it. For example, one can take control of CDN server, right, and just give you a jQuery with malicious code. One new way to actually prevent that is that when you, on your page, when you load something from CDN, you should specify integrity with a SHA, and if a browser downloads the jQuery and computes SHA and compares to what you said, if it's different, it will refuse to run the script. So it's called sub-resource integrity. And you should start using that. Not every browser, of course, as always, but it's a way to go. But here's a worse problem. So a typical server has a bunch of dependencies. We all know that. But it used to be that NPM used to be just for code we used to build, like our plugins and so on. And Bower is something that runs on our client, right? jQuery, Angular, app code, and so on. But now everything is together. Everything is dependency coming from NPM, and then we pack it and we load it. That means that anything from NPM could be a huge security hole and could be potentially packed into our web app code. So let's say you're using this, whatever, negotiator 0.60 in your web app. So what happens if an attacker unpublishes that particular version and publishes new code under the same thing and includes a security hole, a backdoor? You pack it and you use it. What happens if an attacker publishes a patched version with a security hole? Are you going to blindly start using it? Which brings a story from Spring. I call it Kickgate, you know it as the left pad. And the most important thing is this. So a guy had npm package left pad and kick, and there's a company kick, and it went to the guy and said, hey, can you give us the kick name? We want to use it for our brand. The guy said no. Kick, the company, goes to npm, the company, and says, hey, we want to kick as a brand name. npm rolls over, gives them kick name. The guy throws a fit, removes all his packages from npm, including left pad, breaks the internet. But another guy came there, and he published his code under all these names that all of a sudden became vacant, under the same versions, and all of a sudden, everyone who depended on hundreds of packages got malicious code in their code base. Big security risk. npm changes everything back and publishes, and so on. Changes the publishing policy. So now you cannot unpublish anything after 24 hours. But here's the kicker. Let's say you have your own project used by everyone else, right? What happens if you leak, for example, your npm token, right? You notice it right away, and you unpublish it, you scrub GitHub, and you're like, whew, I'm done, right? As soon as something leaks on npm or GitHub, assume there is a bot, but grab the copy of it. So if you leak your npm or authorization token, assume that someone else will try to use it and impersonate you and try to publish a new version. The question is, can someone publish under your name? So every major npm project in the last 5 years, or whatever, 3 years, has leaked something. GitHub tokens, npm, password, SSH keys. It's just ridiculous how much we rely on trust, but we also rely on humans. And humans can commit SSH key, can publish it, and someone else can grab it. The solution is prevention. Security reviews, look at what you commit, don't publish blindly to the public repo. I have a little tool, ban sensitive files, that will look at your commit and will check if you're publishing something that you shouldn't. And this is all being kind of like, oh, things are bad, things are only getting worse. But let's come down for a second and let's maybe finish on a positive note. Most important thing is for you to set the expectations right. Both Angular 1 and Angular 2 libraries, they have 2 excellent pages. And on each page, there is a security explain what Angular framework assumes, what it provides, and where to look next if you want to prevent certain attacks. And I think it should go even further. You're making an app or a framework, have a single page that explains everything about security in your particular application or library. This will go a long way towards setting expectations and avoiding security holes. If you find security flaw and you think it's actual bug, right, it's actual exploit, don't just open GitHub issue because you're publishing that. There are emails on both pages. If you find it in npm, there is a page. Submit it through email so it stays hidden until there is a patch. Okay? And finally, you should review the code, especially at the boundary, periodically. And as the simpler your code is, the better, the more secure it is. The code is rarely simple. And I want to give you something I want to finish with something that I think is just mind-boggling. So function f just pops an alert. Okay? What do you think happens if I do f 2 backticks? Anyone? Okay, I'll give you an answer. It actually runs the function. Okay? And I was like, what? And somewhere in the audience there is Shai Resnick who says like, what? Like, this is absolutely ridiculous thing, and ES6 only is getting more ridiculous, and that's why you should use semicolons. Semicolons stop this kind of behavior. ES6 symbols, for example, I think the next security exploit will come by overwriting the behavior of JavaScript objects through symbols, because they allow you to do completely different behavior in whatever objects you have. Please try to implement security early. It's much harder to secure a system already in production. Try to implement security as early as possible. You will save yourself much grief later. And finally, use crash reporting. Content security policy violations, probing of JavaScript will all generate security crashes. If you know about them, you'll be warned. And finally, if you harden your system just a little bit, you'll make yourself too expensive to hack. Okay? If you're running away from a bear, you don't have to be faster than the bear. You have to be faster than the slowest guy. Stay safe. Slides.